Good day, everyone. I'm Sada, Senior Director Engineering GitHub. Today, I'm going to talk about how software development as a team effort requires special attention to developer experience and its significant impact on productivity. We look at some of the ways in GitHub is solving these hard problems and how we can incorporate these solutions into our development process. Our mission is to build a global platform for developer collaboration. As software has evolved, the journey from idea to production has become extremely complex, involving multiple processes, tools, and services to fit together in an integrated whole and deliver value to the customer. Our focus has and will continue to make this journey as productive and effective as possible for the developer and the team. At the end of the session, I hope to make the statement developer first, cloud native, real for you and your teams with a call to action that will positively impact your business. We spend a lot of time talking with customers about DevOps and their goals. Software development has undergone significant metamorphosis over the years, as has the applications that are being built. I have been part of projects to build compilers, which was in essence a specialized client application. Over the years, I have seen client server morph to web and mobile applications to cloud native services. Business requirements have also evolved from high engineering quality and odd box products that ship with long cycles to services where customer feedback is available instantly to make changes to the product. This obviously has resulted in significant changes to the software development role, process, and tools, as well as expectations. Ultimately, today, this boils down to a single simple goal. We want to accelerate software delivery to provide great experiences to our customers. The software delivery process, which we will call the DevOps pipeline, has a significant number of components. In order to meet the goal of faster delivery, there are multiple areas you can focus on and improve their efficiency. Firstly, the teams need to work together and build atop each other's work to deliver the best value to their customers in the fastest way possible. Removing friction and allowing team members to work together and write code is arguably the number one focus area for teams. As the work flows from one stage to another, from planning to coding to release, any manual step can disrupt flow. Automating workflows makes the flow reliable and smooth, but it has an interesting side effect that I will touch upon when we get there. Consumption of open source is accepted as one of the best ways to bring software to fruition faster. However, ensuring that the application is secure requires vigilance, and ensuring that the source code is safe is very critical. Finally, teams will scale up, and the software tools and services that we use should adapt naturally and continue to be reliable and available. Just like any other software on the planet, software development tools and services are also expected to be modern and deliver on crowd principles. We believe that the best way for enterprises to solve for accelerating velocity is to focus on their developer experience. By creating an experience that empowers your developers to do their best work at work and collaborate more effectively, you're naturally increasing your ability to deliver more innovative and secure software faster. There are three core things that are critical to providing a great developer experience. I'll talk a little bit about developer focused security and compliance. But it requires a completely dedicated session, and there is a parallel DevSecOps track that I would strongly recommend to complete the picture. Generally, we need a fully integrated platform from idea to production as we move from planning to implementation and deployment to product. GitHub provides an integrated experience from one stage to another smoothly, allowing you to trace the flow of value through the entire pipeline. But first and foremost is a collaborative automated workflow. And our session will focus on this specific area and walk you through innovations that bring the ability to build a productive developer experience at your fingertips. So, what is collaboration? As you can imagine, collaboration is in our DNA. GitHub was built originally to support software projects built by globally distributed teams using Git. From its inception, GitHub was created to solve the challenge of allowing developers distributed geographically and working asynchronously to effectively collaborate on code. All of us have used source control systems, and I'm sure many of you are familiar with the concept of a pull request. While Git and pull requests are fundamental building blocks, collaboration is still a challenge all organizations continue to face, and it is critical to accelerating software delivery. Dora frames this as maintainability. Do you have systems and tools which make it easy to find, reuse, and change code maintained by other teams? Add and upgrade dependencies without breaking the code? These systems are key so that you can ensure reliable and continuous deployment of your applications. You can decrease your technical debt, and all of this finally improves your velocity. However, we just said that collaboration is a challenge. So let's look at how collaboration can be a complicated challenge for enterprises. So collaboration starts with organizational setup. Many organizations look something like this: different teams and groups scattered across the company working on specific projects. It can be difficult for you to foster collaboration and code reviews among your different teams. Let's look at a few barriers that developers face in productive collaboration. Finding the right person to connect with. It is cumbersome to onboard onto a project. Just getting the code running sometimes takes days. Different practices and norms. So every team has its own practices, norms, processes, and maybe even code writing practice tools, and even different tools and dependencies that can slow down the collaborative process. Naturally, GitHub can bring you good practices that have helped grow the open source community inside your organization, which is often referred as inner source. But tools are just one part of the puzzle. I want to caution that while we talk a lot about tools, culture, process, and development philosophy underpin a successful inner source transformation. One of the best examples that I can think about in the context of GitHub is the async culture. By default, we assume that the team works in a distributed environment and is remote. We assume that diverse contribution to code is expected and decision making needs to be preserved. So every decision is meticulously documented, debated, and persisted. Many teams use documentation practices that are based on a GitHub repo or an issue or a discussion that we can always come back later to understand the key question of why. However, let us get back to a specific problem that all of us working in development teams will relate to: onboarding to your project and setting up the development environment. I am sure many of us, and in fact, every one of us, have been frustrated with getting our development environment working on that day when you needed to check in an important change to the project. This might be because of a software update, machines that have other project dependencies that conflict with your project, and I'm sure the list goes on and on. And our solution: GitHub Codespaces. As you can see, the principle of Codespaces is to reduce the mean time to code, remove the project switching friction, and simplifies collaboration as well as hardware management, maintenance, and procurement. Let's see what it really means. What is GitHub Codespaces? Most of us are familiar with the concept of containers. Codespaces brings that concept to your development environment. This is a solution to configure your development environment for easy and repeatable use by using dev containers. Like all solutions in GitHub, the definition of the dev container is part of the repo and not specific to a particular user. This is why it is great for the maintainer of a repo to leverage. No matter who the user is, as long as they're using this repo, they're just going to click on that one single button, open in Codespaces, and we're going to spin up an environment consistently and to the specifications that you have checked in. As you can notice, we can bring together the tools, the runtimes, and the dependencies and workflows into the repo as a configuration for the Codespaces environment. Let's take a very specific example. I'm sure we have all switched branches as we worked on issues from multiple releases, and resetting our environment to that specific branch was a cumbersome activity and often fraught with failure. With Codespaces, since the configuration is part of the repo, just switching to a dev container in that branch brings up a pristine environment with zero switching cost and zero friction. I know that we talked a little bit about cloud first principles, and Codespaces demonstrate that very well. You can bring up a container suited to both your budget as well as productivity needs with the computing power appropriate to you and your team. And we'll see more of it as we go through the demo. I'm sure one question is going on in your mind. This all feels good, but what about that particular alias that I use on my machine? I can't imagine a development environment without it. Well, don't worry. We know how important it is for your dev to feel like home, so you can personalize your code spaces in just a few minutes. Dot files allow you to configure how you want your working environment to look like, what shell you want to use, and how you want to customize it to fit your needs. These configurations live in a public repo under your GitHub account. You can define aliases and any other tool just like you want on your local machine. As the Codespaces dev container is spun up, the dot files are applied as part of the creation process, and the Codespaces environment will look and feel just like you want to. Now, all of this is very good. We talked a lot about what Codespaces is about, and we also talked a bit about like how it can actually help your development process. But one of the things that I am growing to appreciate is data, and people who created this content really address that need of mine as well. So let's ask, is code spaces and collaboration really effective towards our end goal of accelerating valuable delivery? And the answer is a resounding yes. As you can see, companies such as AIG appreciate how much this allows the developers to spend time on crafting the product instead of burning time setting up development environments. While it is intuitive for us that an automated development environment configured to run on consistently composed containers will be productive and reliable, it is certainly gratified to see that validated with real usage. It is the key to improving your organization velocity. Take, for example, Nationwide. By adopting inner source practices and tooling, they have seen improvements to project structure and documentation and better development practices and a 90% reduction in merge times. And that's huge because you're saying that now it's going to take 10 times lesser to go merge your code back into master than it did earlier. So today we have both qualitative and quantitative feedback that improving developer collaboration and inner source has a real impact on productivity. Code spaces contributes to that particular goal and our end goal of accelerating value delivery. Let us now go through a demo on code spaces. I have navigated to a repository that the team at GitHub has explicitly put together for this demo. This contains an application that displays a book list. Now first, let us get ourselves a dev environment. As you can see, all I need to do is to click on a single button to create a new code space. I can choose the compute power I really need for my development environment right here. Let's start with the default 4-core environment. Now, while the new code space environment is being spun up, let us take a peek behind the hood. The .dev container folder contains all the information needed to spin up a code space environment. The dev container JSON file contains information about the specific configuration of the demo environment. You can also compose a Docker container to complete more complex setup using the Docker compose file setting. The cool thing about this process is that it is automated and repeatable. Chances of configuration mismatch, dependency errors are completely eliminated. Of course, as you can imagine, there is significant initial investment in generating this configuration, but once it is done, it is preserved. Since these files are part of the repo, switching to a setup on a different branch is as simple as switching to that branch and creating a code space environment in that particular branch. Now that the code space environment is ready, let us go take it for a ride. Let us start off by seeing what the application is all about. The application is a Java application, and we have a Maven build that is happening to generate the required class files. The front end is HTML, and all of that will be packaged, and a new web server will be started once this entire task is complete. The rest of the environment should be fairly familiar to VS Code users. I can use the standard tools and extensions in VS Code directly, browse through code, set breakpoints, and use the powerful editor as I am used to. Now that the build is almost complete, what we can go see is that the web server has been started and I can actually go open the application in the browser. What this environment allows you to also do is to go and redirect ports and as well as use dot files to customize the code spaces environment. And here you go, the application is ready and ready to ship. Let me now focus on another area that is a critical part of improving the developer experience and eventually impacting our goal of accelerated delivery, automation. Many organizations talk about this in the context of CI/CD, but the opportunity for automation is much greater than the scope of CI/CD pipelines. Anytime a developer wants to perform a manual task, context switching, kicking off a workflow, whatever, they are being distracted from the work they and you want them to be doing, which is writing code. So you want to empower and not inhibit developer productivity. Sure, that does make sense, right? Developers need to context switch, but the manual task itself shouldn't take long so they can get back to coding quickly, right? That is wrong. Developers need to be in a state of flow, the optimal creative state where they're highly focused and most productive. And it is 23 minutes, the time it takes to get back in a state of flow when interrupted. So context switching is just not in the moment. It takes away significant productive time. Think about it. If developers are forced to context switch 3 or 4 times a day, that is 2 hours of interrupts plus the time it takes to perform the task that they switched context for. Obviously, the solution is to automate as much of the developer workflow as possible. All of us are familiar with Actions as a CA platform on GitHub, which is growing rapidly. This is an open workflow system that has had significant impact already. It is the #1 CI platform on GitHub and continuing to grow rapidly. There is significant data that Actions have had already on CodeFlow. The time to merge has become 20% faster and 30% more PRs are merged as compared to pre-Actions. Actions is today primarily a CI/CD platform. Like all GitHub services, Actions supports every cloud platform, and our cloud ecosystem partners have developed dozens of actions to make it easy to deploy applications to their platforms. As we go through the demo later, we will see the powerful ecosystem that takes Actions way beyond the realm of a single solution to a platform. In the true spirit of GitHub, it allows sharing of actions to achieve a scenario across multiple users. Automation is not all about CI/CD. As you can see, you can use actions to pretty much automate anything. Any event in the GitHub ecosystem can be hooked to actions workflow. This combined with the APIs to access GitHub or other systems can be used to create powerful scenarios. Microsoft, for example, creates much of its documentation using this approach. As we have said, actions are just source code, reusable components that you can reuse across all your workflows. This means you can create your own library of actions to share and reuse within your organization. More actions are being created every day by our vendor and ecosystem partners. But most impressively, the 50 million people who live and work on GitHub every day are building actions as well to meet every conceivable need. That means the number of actions available for you to adopt and use grows literally every second, increasing the flexibility and value of the GitHub platform at no additional cost. This is truly community-powered development in action. We talked a little bit about using GitHub beyond CI/CD. That also means that you'll be able to automate a significant portion of your software development lifecycle. You could use automated script to react to labels in PRs or issues. You could use triggers to go compile, build, test, and publish artifacts, run linters and security tests, run deployment workflows. As we talked earlier, there is a lot of value that actions actually provide, and it has already been there out for quite a while. So let's take a look at what impact has it really cost. Here is some data that you can actually see the impact and power of automation. Teams that do automation have significantly distinct advantages over their peers. They deploy more often. They cut down the time between code commit and deploy. They recover much, much faster from disruptions. And that is just the tip of the iceberg. Taking a company like 3M, we have seen significant and impressive acceleration, increasing the number of deployments by an order of magnitude, as you can see from 400 to 6,000. Each of these improvements contribute eventually to the accelerated value delivery, which is our ultimate goal. In closing, I want to highlight a few key points. Business velocity is directly related to developer velocity, and the best way to increase developer velocity is to focus on the developer experience. Based on our experience building, maintaining, and evolving the platform chosen by over 50 million developers, we believe these three are the key elements of a great developer experience. Regardless of your desired outcome, whether you're pursuing a full digital transformation or looking to gain incremental improvements in your software development practice, GitHub is a great partner to help you achieve and exceed your goals. Thank you.
Hi, my name is Niroshan Razadare, and I'm part of the advanced security team here at GitHub. It's my pleasure today to talk to you all about developer-first security, the key to migrating from DevOps to true DevSecOps. Today, I'd like to talk to you all about DevOps and DevSecOps. And in the beginning, we're going to talk about the keys to having a successful DevOps program and what it's really going to take to make the next step to have a successful DevSecOps program. Before we go on that journey, it's really important to understand some really fundamental things. Mark Anderson famously said that software is eating the world. And while people initially gushed when they heard this, no one really understood what it meant at the time. What we understand today is that in the next 5 years, 500 million new apps and microservices will be developed. This is far greater than what we as a planet have done in the past 40 years combined. So this opens up the question, what's the key to produce more software faster? At both GitHub and Microsoft, we have been thinking through how the best software development teams work, whether they are teams within an open source community or teams at leading global enterprises. What we found that at the heart of modern development teams is a concept we call developer velocity. Teams that have a higher developer velocity are able to work autonomously and quickly, ship quality code safely, and bridge gaps across their organizational boundaries, even with large-scale teams. If a company can achieve these workflows, it ultimately builds developer happiness, as well as allows them to ship fantastic experiences for their customers. Organizations that work with such teams see results such as being able to set up the dev environment 100 times faster, being able to make 200 times more frequent code deployments. They see 7 times fewer failures and are 8 times more likely to have integrated security. Ultimately, these elite software organizations have 4 to 5 times better revenue growth than their counterparts. Today, we see a lot of our customers facing big challenges implementing DevOps, or they're at a stage where they already went through this change, but the promises that they were promised haven't really materialized. Ultimately, we find 2 consistent themes. Enterprises want to accelerate software delivery to provide greater experiences to their customers. And secondly, they have a number of things they want to improve as part of their DevOps implementation. We believe that the best way for enterprises to accelerate velocity is to focus on their developer experience. By creating an experience that empowers your developers to do their best work at work, you're naturally increasing your ability to deliver more innovative and secure software faster. And there are really 3 core things that are critical to providing a greater developer experience: collaborative and automated workflows, developer-focused security and compliance, and finally, a fully integrated platform from idea to production. So let's begin a little bit with collaboration. Collaboration is in our DNA here at GitHub. GitHub was originally built to support software projects built by globally distributed teams using Git. From its inception, GitHub was created to solve the challenge of enabling developers distributed geographically and working asynchronously to effectively collaborate on code. This is a challenge all organizations continue to face, which has been further highlighted by the global events over the last 1.5 years. It's critical to accelerating software delivery. The folks over at Dora talk about this in terms of code maintainability. Teams that manage code maintainability well have systems and tools that make it easy for developers to change code maintained by other teams, or find examples in the code bases, reuse other people's code, as well as add, upgrade, and migrate to new versions of dependencies without breaking their code. Having these systems and tools in place not only contributes to continuous delivery, but also helps decrease technical debt, which in turn improves what is often referred to as velocity. Let's look at how collaboration can be a complicated challenge for enterprises today. When a developer seeks to collaborate across teams, they encounter a number of barriers. They often experience a cumbersome process to onboard to a specific project, like literally just being able to get the code running on their laptop, to even understand the norms and the nuances of that specific team and code base, and ultimately ship secure quality code. This is where GitHub can help by making contributing to an internal repository as clear and as simple as contributing to an open source one. This is often referred to as inner sourcing, but tools are just one part of the puzzle. Culture, process, and development philosophy underpin a successful inner source transformation, and GitHub helps facilitate change as it was built to support the open source community whose practices enterprises want to emulate today. Take, for example, Nationwide, a big bank here in the UK. By adopting inner source practices and tooling, they saw improvements in project structure and documentation, better development practices, and a 90% reduction in merge times. Another factor in accelerating velocity is automation. Many organizations talk about this in the context of continuous integration and continuous delivery, but the opportunity for automation is much greater than the scope of CI/CD pipelines. We want to empower the developer productivity. Anytime a developer needs to perform a manual task, to context switch, kicking off a workflow, whatever, they're being distracted from the work that they and you want them to be doing, writing code. Not to forget that this can also become a large human security risk. In fact, the impact isn't just the time lost in the moment. According to a recent study, it takes almost 30 minutes to get back into a state of flow, the optimal creative state when developers are highly focused and most productive when they're interrupted. Now let's shift to security. If you're like most enterprises we work with, you're concerned with ensuring your IP stays within your organization while protecting your client's information as well. By doing this, you're also charged with building out and/or maintaining the application security suite for your organization. So let's take a look at what's really going on when we build an application today. When we build an application today, it's no longer the case that we need to build the entire application. In fact, it's more than likely that an application will reuse packages and dependencies that address some of the core foundational capabilities, while our developers focus on the core business experience we want our customers to have. The big challenge here is that as we pull those dependencies, they too have dependencies and so on. So before you realize, there is more code in your application from the dependencies than the developers have written themselves. In fact, in a typical application today, over 90% of the code in it originates from outside of the organization and is very often open source. Fortunately, most of those open source projects and the maintainers who maintain them and the developers who work on them are on GitHub. This is why it's our responsibility to help every organization use open source well. Let's take a look at some examples of how using open source works well. Here's another project, right? So this is the TensorFlow project from Google. It's a data science project. Here, what we can see is we look at the core project, and in there are 2,238 direct contributors. But by the time we look at the transitive dependencies of the TensorFlow project, and we get to the 7th degree of dependencies, there are over 23,000 contributors to this project. This is as big as some enterprises or entire development organizations. In fact, here at GitHub and Microsoft, VS Code, which is our IDE that we have here, has a core team of about 20 people, but there are over 1,000 contributors participating on this project. Every month, people submit bugs and fixes, and here you can see a recent one from an external contributor. And here what we need to do is we need to triage this, make sure it's free of issues, both buggy and quality, as well as security issues, and then merge it in. So we've done this by being on GitHub and using GitHub's tools to shape the way they and we work and collaborate together. Now, the challenge here is when we think about open source packages and dependencies, is it only takes one bad apple to ruin the whole dish. Or in this case, it only takes one vulnerable dependency to ruin the whole application, right? And that could be an intentional mistake, a malicious mistake by a developer, or an accidental mistake, but it opens up the whole application. So this is really a huge challenge when we talk about securing our supply chain coming into our application. The second area is that when we think about how developers and security teams work today, they fundamentally are working in silos, right? Let's look at what happens here. So you're a developer in an organization, you build some software, you get it ready, you do your code test, your CI, and you're ready to deploy. And just as you come in to deploy, you have to clear a security gate. In fact, there's a really interesting statistic from the state of software security that Veracode reported last year. It turns out that over 78% of enterprises only scan their code for security issues between 6 to 12 times a year. So what that means is that over 70% of enterprise organizations today are really only scanning their software when they're getting ready to go into production. And so the problem is that you have to clear the security checks before you can get to this final state. But anytime we find an issue in the security phase here, we have to go back to the start of the process to go and update the software and remediate that issue. And the one thing that we understand really well going from the mid-90s, from the research that Capus Jones did when we used to talk about build failures and software testing, is that it's 100 times more expensive to fix a problem, at this final stage versus fixing it at the developer's desk, right? So that is very expensive. And this friction of blocking developers from getting into production because of the security check when they're under pressure to ship also introduces the friction that we see between developer and security teams. And so as a result of this, the whole industry has been talking about the concept of shifting security left. So what this really means today is we're trying to get the results that were identified through the security checks that the security teams are doing into the developer's hands faster, right? And if we have a look here, you can see the whole industry has been pushing this message aggressively. And this is what then drives DevSecOps. The challenge here is that these tools were all built with an optimization for the security team's experience. Let's think about the mindset of a developer versus a security researcher for a moment. A security researcher wants to know about all possible results. Those that are 100% correct, what we call true positive in the industry, and really need to be fixed very quickly, but also those that are interesting, but may not be exploitable directly, or are okay for now, but could be an issue in the future if certain design paradigms or architectures were changed. A developer wants to know what's broken with the changes that they've made. Presenting speculative or interesting results, or here are all the problems in this particular application, most of which they're not responsible for, is a distraction for the developer to get that piece of work done. They have to review each one of those results and make sure they are or aren't applicable to them. So that slows down the developer experience. And so let's take a look at a little analogy of what's happening in the industry today.
Hey, do something.
Oh, I'm not a security guard. I'm a security monitor. I only notify people if there's a robbery. There's a robbery.
So what we see here is we've taken security tools that are built for notification of issues and put that in front of a developer without helping the developer improve the software that they're building. And so this comes back to our point, right? What's really going on today with the approach that these tools are taking in the industry? So we went off before we came into the space and did some analysis on some really popular open source projects. And so what we did here is we took about 70 million lines of these projects and we went and analyzed exactly what was going on in that. So the first line that we can look at here is the blue line. The blue line is showing the volume of code inside these repositories. And as you'd expect in any kind of active or popular open source project, the volume of code in these repositories is going to increase over time. The next thing that we did is we went and plotted all the commits inside these repositories where there was a discussion of a vulnerability. And so in this example here, you can see in this purple line, until about the middle of 2017, it remains relatively flat. And then from there onwards, there's a huge uptick in discussions about vulnerabilities and remediating inside these code bases. Cause a correlation. This is roughly around the whole PR campaign around the Equifax breach, which really brought a lot of awareness to the industry. Now, what's really interesting though, is if we look at the red line are the number of security threats that are being introduced into this code base. And what we see here is that despite there being growing awareness of security issues from the middle of 2017, the rate at which security issues are being introduced in these code bases doesn't change. So whatever these developers are doing to improve their security posture is not really working. And this is exactly what we see when we look at what's going in enterprise software today. We obviously don't have the visibility into the code and how it's being built, but when we look externally, what we see is that using the Verizon data breach report, over 50% of data breaches today are caused by weaknesses in application security. So the same detailed information that we can see in open source projects is represented by the data that we see in enterprise software. So what that tells us is that developers, whether they're working on open source or enterprise software today, are struggling with remediating security issues, because we have plenty of tools today in the industry that already tell us what security problems we have in our code. And this opens up the conversation. Is there a better way to approach this? So what does it take to deliver complete application security? Well, first of all, it needs to be developer first. Developer first is not the same as shift left. As we mentioned before, shift left is about taking information that the security team want and shoving it in front of the developer's face. That's not the answer. Developer first is about providing relevant information to the developer associated with the changes that they're making at the time that they're making those changes. It's a very different form of information that we provide, highly contextual and highly relevant to the activity taking place. The second thing that we need to do is we need to make this experience native. If you remember when we presented the slide before, it takes approximately 30 minutes for a developer to get back into their peak state of flow whenever we disrupt them and send them somewhere else to do some other activity. So when we think about application security today, we have multiple tools running. And if I'm a developer, I have to look at this tool and this tool and this tool. And then I have to aggregate these tools together to understand what my posture is. I have to even do that as a security researcher. But if we take all that information and bring it into a single pane of glass, the same pane of glass where the developers building their software today, the same way they're consuming build failure information, code quality information from test failures, and security information. If we bring all of that together, we provide the developer with a unified way of understanding the pedigree of the change that they made without sending them to multiple tools. This is going to improve developer productivity because they can stay within the workflow where they are. And the last area is automation. As we discussed before, anytime we bring a manual process in, it opens us up to error, to missing things. So making the whole ecosystem entirely and completely automatable is one of the keys to building a successful DevSecOps program. And so what this means is we need to build security into the developer lifecycle. We need to bring that information into the views and the perspectives that the developers are using today to understand the impact of the changes that they're making. For example, in the screen here, we see a diff view. In this diff view, we attach the security result directly to the change that the developers made to say, hey, you made this change in the code here, right? If you have a look, here's the change in the code that you made, and here is the security issue you caused by that change. This is highly contextual information, which is very empowering for the developer. The other part is today, the whole security industry is working in silos, right? One provider over here is doing optimization and work. Another provider over here is doing optimization work, and we can't exchange and interchange the benefits of that. So one of the key things that we understand here at GitHub is that we've enabled open source software and open source software collaboration. And if we can take that same thing that has made open software so successful and bring that to application security by working with the community and providing a framework for the community to collaborate, we can really transform and unify application security. And this is one of the things that's at the DNA of GitHub today that we're trying to enable in this space. So let's take a look at how GitHub is going to help secure the software developer lifecycle. So the first area that we want to focus on is the supply chain. So as we spoke about before, you need to understand the components that are forming your application. And when you understand those components or those dependencies, you want to understand, are there any vulnerabilities associated with them? Are there any licensing issues associated with them that may affect your IP and force you to disclose your whole application or the source code for your application? And we need to bring that into a workflow where we're not bombarding the developers with information, but actually giving them a workflow where they can work and remediate those issues. We need to do the same thing with the code that your organization is building, integrating into that workflow, identifying potential issues, integrating into all areas of the development lifecycle. For those developer type workflows, maybe we want to run really sharp and really precise queries that provide concrete information and actionable data to the developer so they can take actions. And maybe further down the process, where we're not impacting the developer velocity workflow, we can go and do deeper analysis, run those more speculative queries that the security team can triage, and then progressively get towards the developers, and perhaps in the future optimize to be in a developer first experience. And then finally, we want to provide an ecosystem for trust but verify. And so the key to that is providing a platform for security governance, where we can define guardrails in which developers can work comfortably. And when they start to exceed those guardrails, we can then trigger some sort of enforcement that brings in the security team to guide and coach and mentor the development organization in the right direction. So if we dig into those details here, when we talk about securing your supply chain, what we mean is knowing your environment. What are the components that your application needs today to do its job? Then helping you manage those dependencies, whether it's from security issues or remediating the security issues to staying up to date with the latest versions of dependencies. And then finally, providing a workflow for the community to collaborate and share information whenever an open source package or open source dependency is remediated. Right? If you look at the way it works today, the entire industry scrapes the information from github.com to determine what vulnerabilities exist inside these open source packages. They put that into their database and they license it. This is a highly expensive and manual way of collaborating with the community. And so what GitHub has done is we produce this workflow inside our technology, which means that as a maintainer, you can say, hey, I just remediated a security issue inside this package. Here is my recommendation. Go from this version to this version to remove the security issue from the dependencies that you have. And then I publish that. And just as the same way as your colleague in another team inside your organization says, hey, I recommend you go from version 1 to version 2 of this particular package that we have internally, an open source maintainer is now provided a workflow on the GitHub platform to make that same recommendation to you. So let's take a little bit of a deeper dive here. So in this example here, what I've done is I've taken a fork from a couple of years ago of a really popular open source messaging framework known as ActiveMQ. It's an Apache project. I've intentionally taken an older branch so that we don't discuss anything that might be highly critical, but also it's sufficiently in an interesting enough state that we can take a look at a meaningful example and what's going on. So in this example here, what you can see here is inside your GitHub repository, you have a security tab. And inside that security tab, you have here Dependabot alerts. And this talks about dependency issues inside your application. And so in here, what we can see is that these are all of the dependencies that we have that contain some sort of security issue inside them. We can jump into one of these ones like the JUnit one, and you can see here it provides information saying, hey, here is the issue, here's the remediation that was recommended, more details, what's the criticality of it. and some impact information as well, and so on, and a link to the internet, well, multiple links to the internet to go and learn more about this issue. But what's really interesting here is this is not just about, hey, developer, there's an issue, you need to fix it. What GitHub does with Dependabot is it creates a pull request. And the pull request basically provides all the information between the version of the dependency that your team is on and the version that Dependabot is recommending that you move to. And you can see here the release notes information, all the commits that have taken place. And it creates a pull request to do that for you automatically. So here, as a developer, you just review that all the checks are passed. And if you're happy with it, you just click Merge Pull Request. No effort required by the developer. This means a developer doesn't have to deeply understand how this dependency and its whole dependency ecosystem for this dependency works. They just know, hey, there was a problem. Here's a fix. Please move to this. And you carry on to the next thing. So this can be a very quick remediation. So this is highly empowering for developers. Okay. The other thing is we have like a broad perspective here as well. So you can actually view all of the security issues that exist inside your organization. You can drill down into particular license types that are being used by these particular projects. So for example, here, if we go here to open security advisories, we can maybe focus on the most critical security advisories that exist inside my organization. I can choose one of these. So in here, for example, I can see Django. This has a couple of dependencies inside my organization. If I drill down here, let's just sign in here. So here you can see the dependents that are being used. And I can drill down directly into that. And I can actually look at the project. I can understand what's going on here as well. So this is how powerful this view is, that we can view it from a top level within the organization. So as a security team, I can view what's going on. But also as a development team, I can also drill down into as a security team, I can then drill down all the way to the smallest things and see what the issue is. And then the last thing is, how do I prevent these issues coming into my code? So in this example here, what we're doing as part of the pull request is when a developer makes a change to the manifest file or the dependency definition file, what we can do is we can view what's going on with those dependencies, both at the core level or at the top level or in the transitive closure. And so in this example here, in this Ruby example, I've made a change to the lock file, the manifest file for the Ruby dependencies. And what we can see here is that GitHub tells me, hey, you made a change. Here's the version that you're bringing in. By the way, it's 8 years old. So maybe you should think about the version that you're using. Here's the popularity of this package. So really good for understanding things like typo squatting or if something's not very popular. And here's the licenses associated with it. And then finally here are all the known vulnerabilities for the version that you want to use. And you can see this for all of the dependencies that are being introduced here, both at the top level and at the transitive closure level. This is really, really empowering. This means that when a developer wants to introduce a piece of work that makes a change to the dependency tree, we can proactively prevent that developer from merging that code into the release branch by being able to understand what the impact of that change is. This is really what it's about. It's not just about information and remediation, but it's also about prevention as well. And that's how we want to think about developer-first security. If we come back to our slides here, so the next area that we want to talk about is securing your source code. So here, what we want to talk about is finding and fixing vulnerabilities as the code is being developed by these developers. So this talks about, again, presenting the information as the developer introduces the issue in a perspective where the developer is used to refining or triaging or reviewing the impact of the changes that they made. And so a really good example, as I mentioned before, is this diff view, where we present and attach the issue directly to the changes that are being made. And therefore, the developers can understand what's happening and the impact of those changes. The other area is looking at hard-coded secrets. So we've seen a lot of discussion around this in the industry about tokens or secrets being inadvertently committed in the source code, those being then made visible to a malicious user who's then been able to exploit and extract information from those organizations. And then the last area, as I mentioned, is being able to customize the queries and leverage the community. So the key principle behind our code scanning technology is that it's actually implemented using a tool called CodeQL, which we built here at GitHub. And CodeQL has a foundational concept called code as data. Think of a relational database. In a relational database, you can write an SQL query to look for patterns for the data that are inside that database. In a very similar way, we have a language called QL, which looks and feels like SQL, but it's a logic-based language. And using QL, you can define control flow problems, data flow problems, and deep semantic patterns. All of the queries that CodeQL uses are implemented in QL, and they are published under the MIT license. So anyone can view them, change them. They don't have to share it back to the community. It's entirely up to them. And so what this means is, as a community, if we see a query, and we see there's a bug in the query, or we find a way to improve the false positive rate, the community can make that contribution. Our developers will review it and then merge it into the code base or into the repository if it's of a suitable fix, or they'll refine it so that it's suitable. But it also means that when we come across new threat models in the industry for which there are no static checks today, but it's really critical for the world to be able to look for this kind of problem. So for example, if you look at vulnerabilities like ZipSlip or SolariGate, for example, and those class of issues, if there are queries that no tool has those queries today, QL provides an organization the ability to build a query that can look or prevent those kinds of problems, and then provides a mechanism of allowing those organizations to share those queries back into the community so others can benefit from it. And this is what we mean about leveraging the community to be able to do security application security. So let's drill down into some concrete examples for this. So the first thing that I want to do here is show you code scanning at work. So in this example here, again, I've taken the ActiveMQ project. And what I've done is I've dropped a little config file. So if you have a quick look here, I've just dropped a little workflow file here. And this workflow file basically says, hey, go run code scanning. Here are the languages that exist inside this repository, and go publish the results. So very simple. So not much configuration required to get this running on a project as complicated as this. Once we run that scan, we can initially get a flat view telling us of all of the issues that exist inside this repository. And so in here, what we can see is there are 62 open issues, and over time, 24 of those issues have been closed. And in here, you can choose to view this by the tool that's producing this issue, and we'll get into more details a little bit later on that. We can look at filter by the rules that are being used to check for this. We can even view the status of individual branches and jump into those. We can even filter by severity, so we can filter by CVSS severity scores, and so on. Let's take a look at a very simple example, not really a critical security issue, but I think interesting enough that in the frame of this conversation, we can all understand the power of this tool. Here, what we're looking at is an example of user-controlled data in a numeric cast. What this means is we have some kind of user-controlled data flowing into our application. It doesn't go through any sanitization, and at some point, it gets downcast into a smaller numeric type. This can result in unexpected behavior in the code because we're truncating that data. And so what we mean then is the user control data flows in through what we call a source, and where the truncation occurs is where what we call a sink. So in here, what we can see in this example is we always flag these kind of data flow problems on the sink, and then we show you where are the sources. And so here you can see there are two different sources. So if we look at the first one, it's from this file sendMessage.java, and you can see here there's a request.getParameterMap call. And the second source is from this message servlet support.java, and here it's doing a request.getParameter as well. Now, what's interesting is you see is that these are all occurring in different files. So as a developer here, I have to try and work out what's going on. How am I flowing between these different things? And we have this capability called show paths. Show paths shows us all of the data flow paths from those two sources to that one sink. And here we can jump into the most complicated example, which is 19 steps. So here you can see the call to request.getParameter JMS priority. You see that that flows into this field text. Text flows into as a parameter into asInt. AsInt flows into this return. Here is the return from get send priority flowing into priority. And then you see priority flowing as a parameter into client.send, and et cetera, for 13 more steps until eventually we end up down here where this truncation is taking place. And I can view this across all of the different examples. So the power of this is, as a developer, I can understand how this problem is taking place. And by viewing all of these different parts here, I can choose the best location to put that remediation in. Okay. Now, the other areas that we can take a look at is we don't just tell the developer about the issue. We try to provide enough contextual information that the developer can really understand what's going on. So we provide like the high level, hey, this is what the problem is. Here's a recommendation here. You should validate user input or do some sort of balance checking. And then we provide a code snippet example that says, hey, this is bad. This is the bad implementation. And here is a recommended good implementation of addressing this problem. And then finally, we again provide links to the internet so that developers can go and learn more about this issue. And then finally, we show all of the things that have been happening on this particular issue here, all of the triage steps, whether it was fixed and reintroduced, and this might be areas to explore technical debt if we see the same issue being remediated and being reintroduced. Finally, up here, what we can see here is we also incorporate a standardized triage workflow for any security finding that we have. So the developer can, or security can flag this as false positive, used in test, won't fix. And here, as an organization, you can choose how open or how closed this workflow is. So here at GitHub, we talk about a workflow called trust but verify. So what that means is, let's get out of the way of the developer, provide them the ability to triage or fix security issues. But whenever they triage it and don't fix it, let's flag that up for security to come back and review later. And where it really is an issue, security can open it back up and get the developer to triage that issue or fix that issue. This workflow means that security doesn't block developer productivity. We trust our developers to do the right thing. And security can just monitor all of the exceptions rather than being involved in every case. This is a great way of driving developer velocity. The next thing I want to show you is we spoke about a native view. And when we spoke about native earlier in the presentation, what we spoke about was the developer having to view the results from multiple different tools inside multiple different tools. In this example here, what we're showing you here is we've run code scanning, and code scanning implements an interface that's known as SARF. SARF is a static analysis reference interchange format. What this means is any code scanning tool that publishes its results in that format can be integrated natively inside code scanning to provide that same developer first experience. And so in this example here, I've run multiple code scanning tools. I've run CodeQL, which it didn't find any issues. I've run the Anchor Engine container scanning tool. I run shift left analysis. I've even run TFSec to look at some infrastructure as code issues as well. And what's really nice here is I can see all of that information inside a single pane of glass. I don't have to look at different tools. And in here, I can jump to this particular error. And you can see here, this information is presented from Anchor Engine in the same native experience that the CodeQL results were presented. And in fact, I have the same triage workflow. So what this means today is by applying this kind of platform approach that code scanning allows you to achieve, all of your tools can feed into this one single interface, and you can then plug into that and feed that into your security operations center, into your SIEM tool, into your SOAR strategy, wherever you want, but it's a single integration point. And when you bring in a new tool, you just bring it into that integration point, and immediately all those flows that you built up immediately start to work. This is hugely powerful and hugely efficient, right? Because think about this. Today, every time you bring a new security tool in, you have to build all these workflows out. Tomorrow, if you use this platform, everything comes in and you have a single integration point out. You build it once and it'll scale. That's the power of this approach that we have here. The next thing that we can take a look at is secret scanning. So in secret scanning, what we're looking for are tokens or secrets that are accidentally or intentionally embedded inside our source code. In this example here, you can see secret scanning has detected 8 secrets inside this repository. And we even detect things inside binary files or Excel files. It turns out that Excel files are sometimes a common place for storing AWS secrets. And so in here, for example, if we look at this GoCardless live access token, here you can see the token detected inside the source code. Here you can see the history of when it was first identified and other instances were picked up in which versions. And in here, I can click and I see there are 3 files inside my repository where this particular token exists. And what's really interesting is 2 of these exist in the head node of this repository. One of these exists somewhere in the history. So what's actually happened here is that I use VI as an editor. And what happens with VI is I've got it configured to create a swap file so I can always revert my changes if I want to. And what happened was at some point, I had accidentally committed that swap file into the repository, and I went and deleted it. The problem was the swap file contains the full copy of my source code, which means it contains that token as well. So the nice thing about secret scanning here is we're not only looking at the head, we're looking at the entire history of the repository. And then every time a developer does a new push into the repository, we can go and scan that delta to check if there is a secret in there and then provide or recommend a remediation workflow. This is really powerful. And again, you have the same kind of remediation steps here that are possible before for code scanning. And what's also interesting here is that while we implement many of the patterns, in fact, if we have a look over here, there are, I think, over 75 partners whose tokens we have an algorithm to look for. But if you find that there is something that we're not able to catch, you can also specify your own custom patterns. So if you have a look in here, secret scanning actually allows you as an organization to define your own custom patterns. And you can then build those up, incorporate that into the scan. And what you see here is in this first example here is we set up a scan for an RSA key. And that's being detected using the custom pattern. So that kind of scalability is really, really powerful in what your organization can do. And then the last thing I wanted to show you here from code scanning was how does this all fit into that developer first experience? Because right now, what we've been doing is just looking at the state of the repository as it is. When we talk about developer first before, what I said was, how do we get this information to the developer in the context and relevancy of the change that they made? So in here, what I have is a pull request that I made. So I made some changes to the source code. And in here, what you can see is all the checks have run. And the first thing that we see here is not all of these checks were successful. And if we have a look down here, we can see some of the code scanning checks have failed. If I click the details button here, it will take me to a page to show me the issues that my changes have introduced. Keeping in mind, there are 325 other issues in this repository, but the change that I made introduced 1 new security issue. And the tool focuses me on this problem. So I can now decide if I want to triage this or I want to fix it. But it's hugely powerful because in the past, I would have had to have looked at all 325 issues and worked out what was relevant for me. Here, the tool tells me what's relevant for me. And the next thing is, as I mentioned, it attaches the result to the change that I made. So it's highly contextual to help me understand the impact of the change that I'm making. And what's really nice here is, as we've been doing today for other workflows for reviewing code changes by developers, we can start a conversation. We can mention security. Hey, I saw a security issue identified by this tool. I don't understand what's going on. Can you give me some guidance? Or I can ask a peer to help me review and fix this problem. Or as a manager, I can say, hey, I'm not happy with this. We really do need to fix this. This is an issue in our code. That is the power of bringing this developer first experience, is we can do all of those things that the developer does today for the impact and the changes they're making to application security. And this is one of the few tools on the planet that lets you work this way with security issues natively inside a developer's workflow. So let's come back here to our presentation. So the next thing that we want to talk about, actually, before we move on, I want to talk a little bit about the secret scanning. So one of the things that GitHub has also been trying to do here is, as we think about bringing secrets and secret detection into a developer workflow, secret detection is a highly complicated problem. In fact, No two vendors have a similar pattern today for looking for secrets. So what it means is the industry is plagued by very high false positive rates because of these complex algorithms that are trying to look for secrets. And so this is not just a GitHub problem, this is a problem with secret detection in the industry. So GitHub has tried to provide some leadership in the industry here. What GitHub has gone out and done is defined a standard pattern for what a token should look like. So a slug component, an environment component, the actual secret, and a check digit. And by providing the standard and then working with the community to have everyone build tokens in the same way, the problem of detecting a secret inside our code base becomes trivial. And when it becomes trivial, it means we can start building checks which have a very, very low or close to zero false positive rate. Once we have that, we're able, whenever we identify an issue, to put that immediately in front of the developer, right? And so now what we're talking about is push protection. So before we push that change into a repository, we can now detect if a secret is in there. We can have a very, very high confidence that it's a real result. And we can recommend to the developer, please remove this from the code before you do this commit, because you are about to make a secret live. And we can enforce behavior in the developer. And because the result is correct, we're going to get a strong engagement from the developer. And this is one of the fundamental things that GitHub is nicely positioned to allow the industry to achieve. And this is not just for the benefit of GitHub secret scanning. Any secret scanning tool can now benefit from this particular algorithm or this particular change that we're bringing to the standard. That's how we have to approach this problem, right? And that's how you bring secret scanning into the DevOps workflow, by winning developer trust in the results that we're producing. So the next area is, let's talk about what is the impact of this. So when we looked at the Veracode State of Software Security report from 2020, they told us they looked at over 700,000 application commits. And what they identified was that typically in the industry today, when a vulnerability is identified, within the first 7 days, only 15% of those vulnerabilities are remediated. That number only grows to 45% after 90 days. Let's look at that another way. What that means is that in a typical enterprise application today, 55% of known vulnerabilities are still unremediated after 3 months. No wonder 50% of the data breaches today that are caused by weaknesses in application security. So what can developer-first security do here? So what we saw here at GitHub across the open source community that uses our tools and the behaviors that we've heard from our enterprise organizations is that that remediation rate skyrockets to 72%, 1.5 times better than what the industry is able to achieve today for remediation rates. And this is occurring during the pull request. How long does a typical pull request last? A couple of hours to a couple of days. So almost 40 times faster than what the industry has today, and 1.5 times better in terms of remediation. That is the power of developer-first application security. Okay, so now let's talk about how does a security team, or how does the CISO office understand their security posture within their organization. And so to do this, we have something called the security overview, and we have policies. And so the idea here is, if we have a look at our security overview, in here what we can see is the aggregate view of all of the repositories within our organization. We have an algorithm for determining the propensity for risk inside a repository. I won't bore you all with it right now, but it's very interesting and we can get into more details later if you'd like. But in here, what we can see is what are my most vulnerable issue repositories, which ones have code scanning results, which ones is it enabled in, which one is it not enabled in. I can even view this by a particular team. So maybe let's have a look at our DevOps team here. So if we click this, we can see all the, well, there's nothing there. Maybe let's go with central DevSecOps. Oops, small change. So you can see here, these are the repositories associated with this team in GitHub, and I can see what's going on. This is really powerful. So as a security team, I can go and choose where I want to audit. I can drill down into the details. I can see here, hey, this MCAN2 WebGoat gas demo example has 295 code scanning results. I can click into that and go directly into that repository and see the issues that are there as well. So this provides a really powerful workflow for the security organization. But we also understand that, you know, security teams have their own existing SIEM tools and SOAR tools and other operations tools in place. So to support them, we have a really rich and powerful API that you can use to feed into whatever tools you want, but to also build your own custom tools. And so in this example here, what our team has done is they've taken that information that's coming from the API and they built a summary remediation report that feeds into an issue. And in this example here, we can see all of the repositories that we have inside our organization. We can look at the mean time to remediate for all issues in there. We can look at the total number of issues being identified and the total remediated issues. This is just an example of what's possible. There are so many more things we can do here, but I just want to show you that this API is really rich and powerful, and it really will let you do many, many things. So let's come back here. So the next thing that we want to talk about in conclusion is I want to highlight 3 key points from this presentation. Business velocity is directly related to developer velocity. And the best way to increase developer velocity is to focus on the developer experience. Based on our experience building, maintaining, and evolving the platform chosen by over 60 million developers, we believe these are the key elements of a great developer experience. Regardless of your desired outcome, whether you're pursuing a full digital transformation or looking to gain incremental improvements in your software development practice, GitHub is ready to partner with you to achieve and exceed these goals. Thank you all very much for your time.